2.6, some more derivative rules. First thing, a constant. The derivative of any constant is just 0. If you found the derivative of 8, it's 0. If you found the derivative of 5, it's 0. The derivative of any constant is just 0. The derivative of a constant times a multiple, so d dx cu, you can just move the constant in front. So c times du dx. So for example, if we had y is equal to 3x squared, to get the derivative of y prime, the 3 is the constant in front, right? Just leave the 3 in front, multiply by the derivative of x squared. The derivative of x squared is 2x. So y prime is 3 times 2x, which is just equal to 6x. Y prime is 6x. So if you have sum and difference, you can take the derivatives of each individual term if you're adding or subtracting. So if you have a du dx plus dv dx. So here are some examples here. 1. Find the derivative of each function. So the first thing we can do is we want to rewrite this because you can see the 5 over x. If you recall from the previous lesson, we want to make it into, get rid of the fraction there before applying the power rule. 2x squared minus 5x to the negative 1 plus 6. So y prime is, bring the 2 down, 2 times 2, which is 4x, and then 2 minus 1 is just 1, plus, so it's a minus times a negative 1, so it becomes plus 5x to the negative 2, and the derivative of 6 is just 0. So we're left with this, and then to simplify, y prime is equal to 4x plus 5 over x squared. And that's your derivative for the first one there. So for the second example problem, you first want to rewrite. So square root of x is x to the 1/2 power minus, and we can write so this x to the 6 over 3, we can't change the x to the 6 there, but we can write the 1/3 in front. You can see that'll be the constant multiple rule, and then plus 2 pi to the 5th. So here we can take the derivatives. Y prime is equal to 8 times 1/2 is 4, x to the negative 1/2 minus 1/3 times 6 is 2, x to the 6 minus 1, which is 5. And then 2 pi to the 5th is just a constant because pi is 3.14, so it's just plus 0. And then to rewrite this, we can do 4 over root x minus 2x to the 5th. There's a lot of algebra you need to remember from here, so if you're confused about a rule, please clarify with your teacher because these will all have to be memorized. So here, when does a function have a horizontal tangent line? So a horizontal tangent line, if you can see at this point right here, right? If you drew a tangent line, it would be horizontal. Also, this point down here. These are 2 points where the function has a horizontal tangent line. So the slope of a horizontal tangent line is 0. To find where a function has a horizontal tangent line, we set the derivative equal to 0. So question 3, let's use this graph here. Find the x values of any horizontal tangent line of this function here. So find the derivative. F prime of x is equal to 8x plus 7. And then what we want to do is set this equal to 0 because we're asked to find the horizontal tangent lines. That's why we're setting it equal to 0, because it says that. And then from here you can see 8x equals negative 7, and then x is equal to negative 7 over 8. So yeah, for this function, there's only one tangent line right here. This graph is not the same as this one. That was my bad earlier. All right, normal line. A normal line goes through the same exact point as a tangent line does, but it's perpendicular to the tangent line. So find an equation of the normal line of this function at x is equal to 3. In this case, this graph is the same as this function here. So at x equal to 3, yeah, x is equal to 3, y is negative 3. So we can write here f of 3 is equal to negative 3. So you can think about this as your x1 and your y1. So we want to find the derivative. Goes 3x squared minus 8x plus 1. Because the first thing we want to do is find the slope of the tangent line, and then from there we can find the line, the slope that's perpendicular to it. So right here, and then if we plug in 3, f prime of 3, we get 27 minus 24 plus 1, which is equal to 4. This is the slope of the tangent line. So to find the normal line, you just take the reciprocal and make it negative. So instead of 4, it's going to be 1 over 4 and then make it negative. That's the slope of the normal line. Slope of the normal line. I'll just write m of normal line. 4 was the m of the tangent line, but m normal is negative 1/4. So now we can just plug this into our formula, point slope form. Do you remember this right here? So y minus y1, which is negative 3. So y minus negative 3 is y plus 3 equals m. Because they're asking for the equation of the normal line, we're using negative 1/4 times parentheses x minus 3. And this here is your answer here. Is the function, piecewise function here, differentiable at x is equal to negative 1? So in order to do this, we have to find the derivatives of both sides and then plug in negative 1 and see if they're equal. So if we split this up, if you take the derivative of the top function, well, first we want to check out actually if it's continuous. So if you want to know if a function is continuous, just set them equal to each other. 5x squared plus 3x plus 2 equals negative 7x minus 3. Just rewriting them first, and then if you plug in negative 1 into the both sides, it's 5 minus 3 plus 2 equals 7 minus 3. 5 minus 3 plus 2 is 4, is equal to 4. So the function's continuous. The function here is continuous. Check. Because remember, for a function to test, if a function is not continuous, we know it's not differentiable. But now that we know it's continuous, we have to test the derivatives. So we take the derivatives, the derivative of 5x squared is 10x, derivative of 3x is 3, derivative of 2 is just 0, so I'll leave that blank, equals negative 7. The derivative of negative 7x is just negative 7. So plug in negative 1 for x, negative 10 plus 3 is equal to negative 7, and that's true. So this is differentiable. So the answer is yes. Again, to test whether a function is differentiable, first determine, set the two functions equal to each other, plug in the value that they want. That'll determine if it's continuous. If it's continuous, take the derivatives and set them equal to each other to test differentiability. What values of a and b would make this function differentiable at x is equal to 3? So the first thing we should do is, test continuity. So set these equal to each other, but plug in the 3. So if we do 3 squared minus 3x, I'm sorry, 3a, just a times 3 plus 2 is equal to 3 plus b. See, all we did here was set them equal to each other, but also plugged in 3. I just skipped a step here. I didn't write the original functions equal to each other. We solve this, 9 minus 3a plus 2 is equal to 3 plus b. If you solve, 9 plus 2 is 11, minus 3 is 8, minus 3a is equal to b. So you can see here we're actually stuck. We have a and we have b. We don't know which one. We can't solve for either of these yet. So we can move on to taking the derivatives of both, similar to what we did up here. 2x minus a, that's the derivative of the top function, set it equal to the derivative of the bottom, which is 1. Now we can plug in 3 for x. So 2 times 3 is 6, minus a is equal 1. Subtract 6 on both sides. Negative a is equal to negative 5. Therefore, a is equal to 5. Now we have a. We can plug this in here and find b. 8 minus 3 times 5, which is 15. So b's equal to negative 7 here. There's a lot of algebra and computation in this. Take your time. This is a tough one, but this sets up your fundamentals for the rest of Unit 2, 3, 4, and 5.